page 224 and 225, we're going to look at different ways of using the fundamental theorem just to refresh your memory. So we'll start by looking at number 8. We did some of the odds on this page already. Antiderivative of 20 to 50 of dx. And this is not what we did on Tuesday yet. We'll get there. We're going to do some of those eventually. So how do I handle this? It ends up being subtraction. But you have to find the antiderivative of dx first. What would that be? X. Now, we can put the plus c. Remember that you have to if you don't have these numerical bounds, to the 20 and the 50 there. You have to put plus c. We don't have it here, so we don't have to put it. And what we put as a symbol that we're evaluating from 20 to 50 is that bar. And as Heather said earlier, this is the subtraction piece where you plug in the top number first, and you plug in 50 and get 50, and then you subtract 20, so that answer would just be 30. Now obviously they get a little more involved than that. Okay, let's look at the next one that would have been assigned was 14. And we're doing from negative pi over 2 to pi over 2 of 6 cosine of x dx. See if you can remember how to take the antiderivative of 6 cosine of x. Alright, did you get the antiderivative? Do you remember how to do that? Set your 6 out. What can I take? Basically, what can I take the derivative of and get an answer of cosine of x? Because that's my antiderivative. Sine of x. So we have 6 sine of x. Again, we don't need the plus c, and then we go from negative pi over 2 to pi over 2. And we plug in. So we're going to take 6 times the sine of the top one, pi over 2, and subtract 6 times the sine of negative pi over 2. Now let's see how much you remember off the unit circle. What is the sine of pi over 2? 1. So this becomes 6, right? What is the sine? That was 1. What's the sine of negative pi over 2? Negative 1. So that becomes another plus 6, right? And somebody said 12 earlier, and you were correct. Do you have any questions on that one? I don't know that we're going to do all of these, just enough to get your memory going again. Let's jump to number 20, because that one looks like I've got some u sub there. So it wouldn't hurt to review u sub while we're doing these. So let's go from negative 3 to 3. This is number 20 on that, whatever page that was, 224 and 225. And it has 1 plus the cosine of x to the 4th power. And then there's a sine of x dx on the outside. So what do you think here as far as u sub? Good. The part that's raised to a power is usually what we use for u. So 1 plus cosine of x. Now, what's the derivative of this? What's the derivative of 1? 0, so we can leave that off. What's the derivative of the cosine of x? Negative sine of x dx. And we'll move that negative over to the other side. So if I want to rewrite this expression, and this is where a few of you forgot to do this on your u sub quiz, if I want to rewrite this, I'm going to leave off the bounds for right now. But if I just want to rewrite it using u, what does the 1, I pull the negative out first of all, what does the 1 plus cosine of x to the fourth get rewritten as? U to the fourth. And then sine of x dx is my du. And I've already pulled that negative out in front. So when I do the antiderivative of u to the fourth, there's my negative, and it becomes what? U to the fifth over 5. Now, are you okay if I go ahead, instead of writing u to the fifth, if I go ahead and put my 1 plus cosine of x back in there for u? To the fifth over 5. Now you could pull that out and make it 1/5 or negative 1/5. And we're going from negative 3 to 3 still. So you're going to want your calculator here. You're going to have, and I'll just make it negative 1/5, and we'll do 1 plus the cosine of 3, make sure you're in radian mode, to the fifth, and then we're going to subtract, I'll do brackets here, a negative 1 plus the cosine of negative 3, let's see if I can slide this over a little bit here, give me some room, to the fifth, and I forgot my 1/5 out there, times 1/5, I'll do that. Yes, well, yeah, you could make that a plus with the 2 minuses, or you can type it in as is. Get my calculator up while you all are typing that in. You guys help me watch this time up here because I can't go over 10 minutes. That's why I'm leaving the recording thing up there. And Heather Julia told me to make sure that you remember your plus C's on your indefinite integrals. So I'm supposed to remind you of that often, and I'll just remind everybody while I'm at it. So. Okay, I think I've got all this in here right. Let's see if I get the correct answer. Did you guys come up with 0? Okay, and that's what's in my solution piece there also. Whoops. Let me pull that back up and put it on here. Is anybody having calculator problems? Okay, so is everybody good with just regular fundamental theorem of calculus, not the area stuff that we did on Tuesday? We'll do that next. Is everybody okay with that part? Yes, Felix? The A on these, the A is the bottom number down here at the negative 3, and that's the B. And if it's in the right, well, I mean, they can switch them and move those numbers around, but remember we had properties like if I were to move the negative 3 up where the 3 is and have them switch places, I would still get 0, but technically the rule is that you get the opposite of the answer if you had them from the other direction, but the opposite of 0 is still 0. So is everybody okay on these? All right, I'm going to stop here at the recording because I'm getting close to 10 minutes, and I'm going to have you guys start looking at the section number 27. You can start putting that graph in your calculator for the equation on number 27.